Hello, this video is to show you how to implement a sum of products circuit using NAND logic. Let's assume that I was given a function or a truth table, and I draw my circuit this way. I have ABC as an input. The function is at the output of the circuit. It's AB or A not C. The AB is ANDed over here, and the A not C are ANDed over here, and both of them will feed this OR logic or circuit. So the step I'm going to do is to introduce some bubbles on these wires, these two, this wire and this wire, and I cascaded two bubbles on each branch, which is representing here negation. So the bubble here represents a NOT function. So if I'm going to put a NOT over here and a NOT right after, so that means I'm not changing any logic, and the same apply to the lower branch. So this is just like multiplying by 1 or adding a 0. Right. Now I'm going to try to move this bubble to the left to be at the output of this AND next to it. I'm going to do same to this NAND. I'm going to put it down here at this location. I will move to be next to the NOR, a part of it. Physically will be a part of it. Same here. I'm going to move these to the right to be just like a physical part of this OR. That's what you can see on next slide. So moving the bubbles around, and I removed the AB because now it's become like internal variable of these OR circuit, and also the A not C, which was over here, now it becomes part of internal variable of the OR. Now this is an OR with two negated inputs. I'm going to apply the De Morgan rule because I'm going to consider this input here after the bubble as a negated X, which is X naught right here, and I'm going to consider the other input after the bubble as Y naught over here. And from De Morgan rules, I know that X naught or Y naught is equivalent to a NAND gate. So I'm gonna remove all of these three parts right here, the OR gate with the two inputs, and replace them with one NAND circuit. That's what you can see in the next slide. So removing the OR with the two negated inputs and replacing them with a NAND circuit. And now you can notice that I started from the first slide, had two ANDs in one OR, and I ended up having three circuits, and all of them are NAND. Now you can notice that the function is still the same. We did not change any logic, but it can be written in a different way, which is those two terms are NANDed, these two terms are NANDed, and all of them are NANDed. And that's how to implement a sum of products using NAND logic. A similar way can be done when I have a product of sums. I can implement the circuit using a NOR logic if I'm asked for to do that. Here, let's say I have the function is A or B ANDed with A or C naught. A not or C, right? So this function may be coming from a truth table, maybe coming from an equation, maybe coming from simplifying a keymap, right? So I'm gonna follow same procedure. I'm gonna introduce those bubbles or in series on each branch, and I'm gonna move them around. I'm gonna move it to the left, this bubble here, I'm gonna move it to the left to be exactly at the output of this OR gate. This bubble, I'm gonna move it to the left to be right at the output of this OR gate, and these two bubbles, I'm gonna move them to right to be like a physical part of the NAND gate. That's what you can see on next slide. So I have here two NOR gates and one AND gate with two negated inputs. I'm gonna apply also the Morgan rule, which is saying if I have negated inputs ANDed together, I can replace them with a NOR gate of the not negated, the original inputs before negation. So if I consider this as X naught and this as Y naught, and they are ANDed, I can replace them with X NOR gate. That's what you can see on the next slide. So I replaced the previous AND with two negated inputs by a NOR, and if you can notice now I have three NOR gates, replacing the two ORs and one AND that I start from. The function now can be written in another way. It is the same, but this is the new equivalent. This one right here, two terms north, two terms north. Oops, here is a little error over here. So that's A naught or C. Those are negated. So this is the equivalent. Everything is ORed and negated. So that's an OR. I have three NOR gates. Hopefully this will help you understand how to implement the product of sum using NORs or sum product using NANDs. Thank you.